Here we have a new Specular Metrology capture device, Sony camera, motherboard, NVIDIA Orin Nano, 40 trillion operations a second. We're going to start a capture pass. So here we have the diffuse lights at the top and the edge lights here at the bottom. These are all going to be processed in under a second, and now I can see our initial, median or diffuse image. The problem is it's really hard to tell the difference between white ink and shiny solder. There's no difference from the perspective of a traditional image. So instead we're going to use the photometric properties we've created from these edge lights. So this is what we call a specular map, and you can't see the R20 because that's ink that's not shiny. Instead we can see the metal, the solder, very clearly as white. So we can test for solder. We might want to check something is present. This resistor is hard to see. If we go to our normal map or our edge map, we can clearly see that resistor exists. And what's more, we can generate an estimated depth map, and that makes it even more obvious. So we can clearly see what's present, what orientation it's in, or whether it's missing. Now let's view this in VR so you can really get a sense of this. So we're going to jump in and we're going to look at these resistors in the bottom corner of this motherboard. You can see the two resistors closest to C81 are clearly present, whereas the third resistor is missing and just the solder pads are there. And you can see all the different reflectivity. This is a carving, we've scanned using the same system, and you can pick up the fibers of the wood and the individual shapes of those grooves as you illuminate it.